You know, museums are incredible, right? They're packed with the most amazing stories from human history. But let's be real, sometimes they can feel a little flat. You're staring at these priceless artifacts, but they're stuck behind glass. Well, what if VR could just shatter that glass? Today, we're going to dig into the blueprint for making that happen, the right way.
Come on, be honest, you've been there, right? You're walking down this long, quiet hall, trying to read every single little sign, and your eyes just start to glaze over. It's a real thing. It's called museum fatigue. You want to feel that connection to the past, but instead you just end up feeling kind of tired and disconnected.
But imagine this. What if you could actually step through the glass? What if you could pick up that ancient pot, turn it over in your hands? Or better yet, what if you could stand right in the middle of ancient Rome while it's being built around you? That's the incredible promise of VR. It's not about just looking at history, it's about stepping right inside it. But, and this is a big but, an experience like that doesn't just happen. It takes a really smart plan.
So here's how we're going to break it all down. First, we'll go through the blueprint for building a VR museum. Then we'll get into the inspection phase, which is all about choosing the right way to test it. All right, let's get into it. Part 1, the blueprint. The secret sauce for building these amazing human-centered experiences is something called design thinking. And look, in a wild new frontier like VR, you're not just designing what's on a screen, you're literally building a reality. So starting with a human being at the center of it all, it's not just a good idea, it's the only way to get it right.
So what is design thinking? Well, at its heart, it basically flips the old way of doing things completely upside down. Instead of building some cool new piece of tech and then just hoping people can figure out how to use it, you start by asking, who am I building this for? It's a 5-step process that puts the user at the absolute center of your creative universe. Seriously, they're the sun, and everything else orbits around them.
And these are the 5 stages right here. Empathize, define, ideate, prototype, and test. Just think of this as our roadmap for the next few minutes. We're going to walk through each one and see how you would actually build a world-class VR museum from scratch.
Okay, stage 1, empathize. This is ground zero. Everything, and I mean everything, starts here. Before you even think about code or graphics, you have to get out of your own head and try to live inside the heads and hearts of the people who will actually use this thing. What do they really want? What drives them crazy about current museums? What would make them light up?
And this isn't just some vague, fluffy concept. It's super practical. You're not just sitting in a room guessing. You're out there talking to people, a whole range of them, from a 10-year-old on a school trip to a history professor. You're literally going to real museums and just watching. Where do people stop and stare? Where do their eyes glaze over? You're like a detective hunting for the real human problems hiding in plain sight. Things like information overload, or maybe even physical accessibility issues.
So, after you've done all that detective work and you've got this mountain of observations and interviews, you hit stage 2, define. This is where you take that big, messy cloud of information and distill it down into one single, laser-focused problem statement. Think of it like your North Star. It's the one thing you can always look to make sure you're still heading in the right direction.
And check this out. This is a perfect example of what a great problem statement looks like. Notice how specific it is? It tells you who you're solving for, the visitors. It tells you what they need, something immersive, interactive, and accessible. And crucially, it tells you why they need it, because the old way just isn't creating that deep, personal connection. From this point on, every single idea can be checked against this one sentence. Does it help solve this problem? Yes or no?
All right, we've got our North Star. Now comes the really fun part. Ideate. This is the brainstorming phase. With that super clear problem in front of you, the floodgates open. You and your team just let the ideas fly. The rule here is simple, quantity over quality. No idea is too weird, too big, too out there. You're just trying to get as many possible solutions on the table as you can.
And this is where you can really dream big, right? How might we solve that problem? Well, what if you could literally have time travel rooms? Or what if a little holographic Leonardo da Vinci popped up to be your personal guide? How about being able to pick up and inspect any artifact you want? Or maybe you could go on a tour with your friends who live on the other side of the planet? This is where the magic really starts to take shape.
Okay, so you've got a ton of awesome ideas. But ideas are just, well, they're just ideas until you make them real. And that's where stage 4, prototype, comes in. Now, we're not talking about building the final, super polished, expensive thing. No way. We're talking about building cheap, rough, scaled-down versions of your best ideas. The whole point is to learn fast and fail cheap. It's about learning, not about perfection.
And a prototype can mean a lot of different things. On one end, you have low-fidelity prototypes. This could be as simple as sketches on paper or maybe some 2D mock-ups. They're super fast and cheap. On the other end, you have high-fidelity prototypes, which are a bit more realistic. Maybe an interactive 3D model or a basic VR room where you can actually walk around. The key is to build just enough to test your biggest questions without wasting a bunch of time and money.
And then comes the final stage of the loop, test. You take that prototype, whether it's a paper sketch or a simple 3D world, and you put it in front of real people. This is the moment of truth. This is where all your brilliant ideas and assumptions collide with reality. You just watch, you listen, and you learn what's working, and, maybe even more importantly, what is totally not.
You're asking simple questions. Can people figure out how to navigate? Are they actually engaged, or are they bored? Do the controls feel clunky? And here's the thing. Finding problems at this stage is a huge win, because every problem you find now is one you don't have to fix later when it's super expensive. And this whole thing becomes a loop. You prototype, you test, you learn, you repeat. With every single cycle, you get closer and closer to something truly special.
Okay, deep breath. So, we've gone through the whole design thinking process, and now you've got a prototype you feel pretty good about. That's awesome. But now we have a new question. How exactly do you test it? How do you pick the right evaluation method? Well, that brings us to part 2, the inspection.
So you've got this prototype, but is it actually any good? I mean, you think it's good. Your team probably thinks it's brilliant, but you can't just go on gut feelings. You need a solid, structured way to figure out if the user experience, the UX, is really working. And it turns out there are a few different tools for that job.
When it comes to testing, you can basically group the methods into 3 main buckets. On one extreme, you've got inspection. That's where you bring in experts to review your work. It's super fast and cheap, but the downside is you might just be hearing what you want to hear. On the other extreme, you have purely empirical testing. This is the full-blown scientific study with tons of real users. The data you get is rock solid, but man, is it slow and expensive. But right in the middle, there's a kind of best of both worlds approach.
It's called Quasi-Empirical evaluation. Yeah, I know, it's a total mouthful. But the idea behind it is actually really simple. Think of it as the Goldilocks method. It's not too hot, not too cold, it's just right. It's a hybrid approach that mixes the expert guidance from an inspection with real feedback from a small handful of actual users. You get the best of both worlds, really.
So when would you actually use this balanced approach? Well, it's perfect for a bunch of situations. Say you're on a super tight budget or timeline. Or maybe your design is still in the early stages and you just need some quick, solid feedback to know you're on the right track. And think about this. What if you're designing something super specialized, like a VR tool for surgeons? Good luck trying to recruit 50 of them for a study. But getting feedback from just 2 or 3, guided by an expert, that could literally be a game changer.
So at the end of the day, it's all about finding the right balance. You're always making a trade-off between speed and accuracy. The expert inspection gives you tons of speed. The big empirical study gives you incredible accuracy. And this quasi-empirical method, it lives right in that sweet spot in the middle, giving you a healthy dose of both. For most projects, that's exactly what you need to keep moving forward without flying blind. So let's just pull this all together for a second. We've talked about the human-first approach of design thinking and the smart, balanced way of testing with a quasi-empirical method. All these frameworks, all these steps, they're really all about one single goal. It's to make sure that what you build isn't just a cool piece of tech. It's to make sure that when someone puts on that VR headset, they don't just see a museum, they feel it.
And that, right there, is the big takeaway. You can have the most powerful, mind-blowing technology in the world, but it's completely useless if the experience itself isn't intuitive, engaging, and just human. Whether you're designing a simple app or a whole new virtual reality, great design always, always comes back to having a deep, tested, and real understanding of people.